All right. Okay, hello everyone. I will be doing the next workshop now, which is going to be covering some of the Arduino basics. A lot of you have started filtering in now, and a lot of you are doing a really good job in getting some work done, which is good to see. I'm going to be going over some of the Arduino stuff because there's a lot of sort of things that come to it, and yeah, let's jump into it. So this is the main layout of an Arduino Uno board. I believe this is the exact type that we have. This is good. It's got all the pins there for you. I think the main things to keep in mind is that you've got on the left side, you've got your V in and your ground. This is mainly where you want to power your board. So keep in mind, these Arduinos are rated to be run at 5 volts, and you have been given 9-volt batteries. So if you are currently powering your Arduino with a 9-volt battery, I'm very concerned. Please don't do that. But yes, so get a voltage regulator. We have plenty of them. If you are unsure how to hook it up, let me know. But yes, so you can power those from the VN pin, and then obviously you need to ground all of your circuits. And you've got your analog pins and your digital pins. Note that there are PWM pins for pin 5, 3, 6, you know, all of these ones with a tilde next to it. They're quite useful because they all have the capability for you to run motors off them. So if you are using any kind of movement, if you are moving something, controlling something, it's a great way to do it. So yeah, so let's jump into like the basic IDE. So this is essentially the hello world of the Arduino world. Blink is a great little fun program, and you all have access to it when you download the Arduino IDE. So I would like to just have a look and show you. This is a new scratch, a new file. This is what you will see when you open up the Arduino software for the first time. And what essentially happens is you go File, Examples, and in Basics, because you are just starting out, you get Blink, right? And this is a great little program. It'll open a new one. It won't ruin the one you currently have open. And it just got this. So let's see, can I zoom in on this? I can there we go. That's the wrong way. Oh God. Did not practice this. Why? Okay. Can I zoom in? That's serial monitor. I don't know how I did that. It's not. God damn it. Sketch. Font size. Did this? No. I don't have like a mouse either. This is really annoying.
Try to go to edit, and then there should be an option to increase font size.
No, it's not. Is it the font size?
Yeah, it might be font size. Yeah, it looks like it's increasing. Keep changing.
Yeah.
In this bottom, this.
Yes, I think I ruined it.
Switch on the button. Hey.
Yeah, that's what it was meant to do. Okay. I just wanted to zoom in. All right. So, sorry, my trackpad was not having any fun time. So, in the void, the main things that we want to go over is that here we've got a void setup. So the void setup is the code that will run only once. It's the spot where you can initialize all your variables. It's the spot where you initialize like serial communication if you want to do that. It's the spot where you can set what your pins are doing for the rest of your program. This is the area of your code that will always run at the beginning of your code. It's hardwired to run at the start. and it will only run once. And then you've got your void loop, which is the rest and the bulk of your program. Loop simply means that it will keep looping over this area of your code. So from these digital writes and these delays, they will keep happening over and over again, whereas this will only run once. So most of the bulk of your code will be run in this area. So all it's doing right now is there is a built-in LED on your Arduino, and we're going to set that as an output. Now, what this means is that we are sending information out to this LED, so it becomes an output. If you have a motor, that is an output. If you have a sensor, that can sometimes be an input. Because if you are collecting data from a device, if information is coming into you, that means that it is an input where you need to tell that pin that it is expecting information to be received on that pin, if that hopefully makes sense. Whereas if you have an output, then you need to let that pin know, hey, you're going to be used to send information rather than receiving, okay? So that's why this pin mode is quite important, is because it actually initializes our pins to make sure that they understand what I need them to do. In this case, I'm setting the built-in LED to output. And then all I do is I write to those pins. So high means that I'm turning them on. In programming, this basically just says that if you've got an on or off switch, this is high means high voltage level and low means low voltage level. So the reason it's not just a straight 5 volts or 0 is because it's often not. 0 tends to be very close to 0, or low tends to be close to 0, and high tends to be close to 5 volts, but not quite perfect. So it just says it as high, and it's just an accepted argument that Arduino IDE uses. And then a below there, you've got the delays. So yeah, you go back to this. Cool. So that's where you can find that. Here's another breakdown of it. So you've got all the comments, and they're great because especially when you've got all the example codes, you can actually you can find who made them. You can find more extensive documentation on them, and it's really, really nice that they're giving you these links to go and explore further. You've got the setup function and you've got the edit function, which we just went over. So yeah, it initializes everything, and then that's what you actually run. So you can, of course, use an external LED, and it's not much of a difference to change the program that we just talked about to go for an LED pin. So the way to do that is trying to put a resistor in your circuit, because it means that you won't blow your LED. Your LEDs will probably be fine in all honesty, but it's a good practice to have a resistor in there just to make sure it's not, you're not overworking that poor little light source. But if we're gonna go in the blink, all we need to do change something like this is let's initiate a new variable. So I like to make everything a variable so that I can keep track of it much more easier. So I can go int LED pin equals like, oh, that's not a, is something like, I think 13 is the one that they like to use in examples. You could use any of the digital pins, it doesn't really matter, as long as the pin in your code matches the pin that you have connected physically up to your Arduino, you'll be all good. And then instead of referring to our LED built in, we are going to refer to our LED pin instead. So I can copy this over to all the different ones. Again, it's still an output. I'm still outputting information and turning a pin on and letting that pin know that it's that. So now it's going to turn my LED, my pin 13, it's going to turn that on for a second, and then it's going to turn it off for a second. This delay function lets you essentially make the program wait, and it's calculated in milliseconds, which is why this is waiting for a second. Okay. So yeah, that's all we would actually need to do. As long as you connect this pin 13 up to your LED, it should blink, and it's probably a nice thing to try out if you're up to that stage, if you're down to do that. So yeah, external LED, quite useful. And here's again the changes you need to do. Again, here I've used pin 10. It doesn't really matter which one you use as long as it matches. Cool. So you can add a button. If this is another thing, if you want functionality that has a button or any kind of like interactive element to it, you can use the same logic probably for sensors. And you can find this code again in the example section of the IDE. I recommend everyone, if they are struggling or they're not sure what to do, this is an exceptional library of many different things that you can find. And one of the beautiful things is button. So I believe we can get a button code. It's in digital, and there you go. Turns off a light emitting diode connected to digital pin 13. So it's essentially using the exact same setup as we had before, but now it's going to use that LED with the button. So it will thoroughly explain to you again the circuit, with a resistor for practice. And yeah, 10K is a lot, but yeah, that's fine. Anyway, constants won't change. So constant int, because these are pin numbers and we don't actually want these to change ever. And then if we need to get a variable to store a button state, because we need to make sure that we can actually compare this value to something else. And it's just all about making these into many different variables. We initialize our LED as an output once again. Here they've called it LED pin and they've made it 13 again. And then we've got our button hooked up to pin 2. So then it's going to say bin mode button is an input. The reason this is an input is because we are checking and we are reading off of the button. We are going, what's the state of our button? And when that button gets pressed, information comes into our Arduino, and then we use that information to do something with it, right? So now we check for the button state. So this is where that variable comes in handy a lot. Digital read. So we read the state of the pin. If that pin says I have 5 volts, it will go to high. And if that pin says I have close to 0 volts, it will go to low. Okay, it's just an on and off switch. So a button is essentially a switch. It's just a switch with a top hat and a monocle, trying to not to be a switch. But yeah. If it is, then the button state will return high. So if your Arduino goes, hey, I've got a high voltage, about 5 volts on that pin, it will set the button states to high. And if it does not, then, well, the only other option other than high is low. So we simply go else. But yeah, and then based on that button state, we write high or low to our LED pin, and it will work the exact same. So yeah. That's the main way that you'd implement something like a button. So obviously, if you have something like an ultrasonic sensor, you could maybe make like an ultrasonic sensor state, or you can, and then you can check based on what your ultrasonic sensor is reading and make a similar if statement for other kinds of sensors or other kinds of buttons or interactions you're doing. So this is a really useful sort of baseline program and laid out in a fairly basic sort of simple way. Relatively simple. It's still C, but we live with it. So yeah, adding a button. And so now verify that you can blink. It's built in is quite a good one. Try that example code. If you literally go into the IDE and you go for the blink one with the built-in. So I should just go into file, examples. It's really good to make sure that you can actually compile and run a piece of code. So, it's still open, go away. It's still open, so I can do it again. File, examples, basics, link. So, this one will have, by default, your built-in LED. It's a little LED that lives on the Arduino itself. So it's a little green LED that will start flashing if you upload this program to it, and it will take about a second. So it's a good way to verify that your method of compiling your program and stuff works, because we know this program works. Other than that, building a bit of an LED circuit is a proof of concept, so you know what's going on. It's probably nice as well. And adding a push button if you want to do that. You don't have to do these things, but they're nice to be able to make sure you understand what's going on. But yeah, cool. That's probably most of what I wanted to cover with it. Did we have a question? The motors. So we are covering motors in a different tute a little bit later on. Motors are a little bit more complicated. You will need to be using the motor drivers that we have got, and they have to be controlled using PWM signals and a battery voltage. So if you are up to the point where you want to use a motor driver, come see one of us and happy to help you out. But yeah, we will be covering that in a later session as well.